Hello world, and welcome to another video. Come for the education, but stay for the motivation. Today we're going to continue a series on cracking the coding interview, and we'll be solving a problem called partition list. Feel free to pause the video just to read through what the problem is asking for, but I find examples a lot more descriptive. So given a list like this input list, we want to return a partition list in such a way that we're given a partition or a target value, in this case 5. All values less than 5 are on the left of the list, and all values greater than 5 are on the right of the list, greater than or equal to 5. But this also happens to be a LeetCode problem. This is what the LeetCode problem looks like. So without further ado, let's get right to it. But first, our motivation of the day comes from Kobe Bryant, and I quote, "Great things come from hard work and perseverance, no excuses." A lot of times life can be difficult, especially when you're trying to learn something new. It can be so difficult, it feels like you hit a wall. But if you keep going, if you stay focused and keep working hard and try not to give any excuses, it will be worth it in the end and you'll get to whatever your plans are. So back to the problem. Using this example from LeetCode, we're given the target value of 3 and we want to partition the list in such a way that values less than 3 are on the right side and values greater than 3, less than 3 on the left side and values greater than 3 are on the right side. So here's how we're going to solve it. We're going to define a function called partition. And this function is going to take the head of the list. We know this right here is our head. And then the second input to this function is going to be our partition, in this case x, or you can call him our target value. So now we're going to partition this list by creating 2 nodes or 2 linked lists. Let's think of it like we're creating 2 new linked lists. So we're going to call them left and right. And we're going to set them equal to node. To be honest, you can put whatever value you want in this node. But in my case, I'm going to put in a value of 0, but it doesn't matter what you pick. So effectively, what this line of code right here does is it creates this node and this node, our left and our right nodes. It gives them a value of 0. And like I said, this is left and this is right. Then next, we're going to create 2 pointers, which I'm going to call left tail and right tail. And you'll see why I choose these names in a second. And we're just going to set them equal to our left and our right nodes we just created, respectively. So effectively, this is what it looks like. Our left tail is right here, LT, and our right tail is right here, RT. Then after this, our next step is to iterate through our linked list using head. And as we see each value, we compare it to our target value. If it's less, we put him on the left side. If it's greater, we put him on the right side. And here's how we're going to do it. We're going to say while head. As long as head is not none, as long as he has a value, we're going to check each value. If head.value is less than our partition value x, if he is, we're going to add to the left side of our list. So lt.next is going to be equal to head. Then we're also going to move our left tail so that he can always point to the end of our left list. And you'll see what that means in a second. Else, meaning he's not less than our partition value. He's either equal to or greater than our partition value. We're going to do the exact same thing, but for the right side of the list. And then we're going to move the right tail so that he's always pointing to the end of our right list. Then after this, we're going to move our head pointer. Because again, like I said, we're trying to iterate through our original list. Let's go through this first example. Now, head is pointing to 1. So we're going to take 1 and check. Is 1 less than 3? Our target value 3? Yes, he is. So what? He belongs on the left side. So we're going to say lt.next equals head. This is lt right here. lt.next is this pointer right here. And we're going to set him equal to head, which is node 1. Then we're going to go on and move lt, left tail, to the next. We always want to make sure lt, our left tail, is at the end. And also we're going to go ahead and go out of this if statement and then move our head forward so we can iterate through our original linked list completely. Then next, we're going to go back to the top of the while loop. Do the exact same thing. Ask, is 4 less than 3? No, 4 is greater. So obviously this belongs on the right side. So we'll go into the else block right now. So rt.next, rt is this pointer. rt.next is the next pointer. And we're going to set it equal to head. And what is head right now? Head is 4. And then we're also going to move our right tail, our RT, just to make sure it's always pointing to the tail of our right list. We're also going to move our head so we can iterate completely through our linked list. So now head is on the partition value 3. We're going to ask the same question. Is head.value 3 less than target value 3? No, they're equal. So obviously he belongs on the right side. So rt.next equal head. So rt is this pointer right here. rt.next is this. It's going to be equal to head, which is 3. And then we're going to move rt forward. Okay, and we're also going to move head forward. At this point, I think you can see, you get the gist of what we're doing. We're just partitioning it to the left and to the right. Again, we're going to check 2 and 3. 2 is less, so 2 goes to the left. 2 right here, and also LT moves, and head moves after LT. Now 5 is greater, so 5 belongs where? On the right. You guys know what's going on. And then RT moves to the last element. Now head is going to move forward. Then now 2 is less obviously, so we know this guy belongs on the left side. And then LT is going to move forward to point to the last element of our left list. So at this point, head is going to move forward, head is going to move out here to none, and then that will cause our list to break. Our loop to break, actually, not our list. So at this point now, we want to connect our left list to our right list somehow, because you can see there's no connection. And the way to connect it is to say, connect this last element, LT.next, set him equal to our right, which is our first element and right list, dot next. Remember, this 0 is a dummy node. They're both dummy nodes. We don't need them. We just created them just to help us build our list. So we're going to say LT equals right, not RT, dot next. So what this does is, this pretty much creates a next pointer from here and points it right here. So right now it looks like we're done, right? But no, actually there's one issue with this code we have right now, and here's the issue. We start from the left, we go 1, 2, 3, we partition the lower guys. Okay, then we go to 4, 3, 5. But this 5 is the exact same as this 5 here. And guess what? This 5 here in our original list is connected to 2. His next pointer points to 2. So technically this 5 down here in our right list also has the next pointer pointing to this 2 right here. So this is what we call a circular list. We're stuck in an infinite loop where our list just keeps going around and doesn't have a none to terminate the list. To fix this problem, we're gonna have to say our right tail dot next equals what? Yep, you guessed it, none. So what this effectively does is breaks this pointer and points him to none, effectively terminating our list. So at this point we can go ahead and return. But what do we want to return, right? We can't return left, even though left is the start of our list, but we have to return left.next, because again, this was a dummy node created to help us build our list. It's not really part of our list. So left.next. Without further ado, let's go ahead and show what this looks like in our actual code editor. This is our code editor. I've gone ahead and created the node class, which is the building block of a linked list. Then I've created our linked list and assigned the first node, the head node, with a value of 1. Created the append function so we can add to the linked list, display function so we can visualize and see our linked list. And now this is the actual function, right? As you can see, once we run this, we've successfully partitioned this linked list just like we wanted, just like we described here. 1, 2, 2, 4, 3, 5. 1, 2, 2, 4, 3, 5, none, boom. Again, it's a LeetCode problem. This is the exact same solution. Let's go ahead and submit it. Accepted. So that's it for this video, guys. I hope it was helpful, and I'll see you in the next one.